So hello again. This is Roger Koch Barr for the Bioelectricity course. This is week 4, segment number 11, and I thought it would be good here to have a bit of a problem session. Suppose we consider this question. We begin with the standard conditions. The tissue is active. At the moment, the state variables are those of set 1, so there's no stimulus. Here are our questions. What is Vm after one time step if each time step is 50 microseconds? What are Nm and H after one time step? And then what is Vm after 2 time steps? Question A. This is very similar to the question, maybe the same as the question asked in the previous problem session. So I'm sure you can work it out and get Vm1. So go ahead, please, and read that back or get it again and write down what Vm1 is equal to. Nm and H were not done before, but an earlier lecture outlined the algorithm. Follow those steps and get N1, M1, and H1. You will have to evaluate the alphas and betas, all 6 of them, in order to get dNdt, dmdt, and dHdt. Now here's the tricky part of this question. What is Vm after 2 time steps? So it is tempting, very tempting, to just do the first calculation again. So I'll write down, do part A again with the question mark. And the answer is, well, no, not quite. So I'll make a note, not quite. To go from Vm1 to Vm2, you need to use N1, M1, and H1. That is to say, not the original values of N, M, and H, but the new values of N, M, and H. And if you do that, you should be able to get it just fine. Let me say another word here just about the synchronization of all these calculations. You will find, I believe, that if you start off with Vm, N, M, H, and use this set of values to get Vm1, and to start with these values, get Vm1, start with these same values, get N1, M1, H1, your life will work out a lot better than if you do the following algorithm, starting with Vm, N, M, H, to get Vm1, and then use Vm1 to get N1, M1, H1. Because if you start with these original values, get a new Vm, then you might use that new Vm to get new values for N, M, and H. So I'm suggesting to you that you not do that. Because if you do, you'll get very confused as to just what comes from what. Your program will have errors in it, or your calculation will have errors in it. You'll get all confused in trying to figure out what came from what. Just keep it simple. Let everything new come from this set. Don't intermix changes in one thing with changes in the other. I think you'll find it works out a whole lot better in the long term. Thank you for watching. I'll see you in the next week's work.